Perfect. Thank you, Sarah. Thank you. So, physicists are often fascinated by mysteries of the universe. And yet, these mysteries also often remain light years away from reaching a broader audience. And actually, here we all acknowledge that science communication can here be effective in bridging this gap and making physics concepts more accessible and engaging to a broader audience. So now that I have your attention, nice to meet you. As Sarah said, my name is Sabine Heij from the Netherlands, Leiden University. And I actually have a background in the beta sciences, both for my bachelor's and for my master's, which I just graduated. And throughout my master's track, I realized that I wanted to move away from the lab and move towards the people. So I actually did a specialization in business studies as well. And I did a specialization in science communication. And that's where I really found my passion. And it's also what brought me here today, actually. Because I was given the opportunity to do a research internship at the Science Communication and Society Department at Leiden University. And this is also where I met Julia Cramer. And here I actually present you today the study that we performed. So before I do that, I really want to take you through a visual journey of how I got here. So it all started at NWL Physics 2023, which is a conference in the Netherlands, but I will talk to you about it more later. But here our project really took shape. Then after the end of our study, I actually also got the opportunity to do my first work in science communication because I was able to write a popular science article in the Dutch magazine for physics, which was really cool. And I also organized a symposium for my fellow students at the Science Communication and Society Department, where we really could share our insights both into the research areas, but also really into the practicalities of science communication, for example, across different science centers. So now that you know a little bit about me, I want to know a little bit about you. So by show of hands, please, how many of you read something about physics on a regular basis? Okay, so maybe 30%. That's actually more maybe than I even expected. But we do know that on average, people with higher levels of education are also more interested in following news about science in general, which includes physics, of course. So I think this may already be an overrepresentation of the general public that would be interested in reading physics on a regular basis. So this also brings me to the framework of our study, which was science communication mental models. And I think Mike also touched on this yesterday. And just to recap briefly, science or mental models are actually internal representations containing meaningful declarative and procedural knowledge. So both really the facts and the data, as well as how things work, which people use actually to understand specific phenomena. And we divided the mental models into 3 categories, which has also been defined in literature. So the first is the public understanding of science, which we all know by now. And I can also go through this quickly. So we know this is really a deficit model in which the public doesn't really influence the scientific discourse. Then there's more the public engagement with science, so the two-way communication street, where there's a dialogue, and it really allows for science to be integrated into society. And lastly, strategic science communication, which I think John will also touch upon after me. And we really focused on the personal gain aspect of strategic science communication. So where scientists really use communication as a strategic tool to build their image or reputation in academia. And when we think about these mental models, we also have to think about what kind of factors may influence attitudes towards these mental models. So the first is career stage or academic age. For example, a professor may view science communication differently as compared to a PhD student. And then there's also gender or your social cultural background, which can affect attitudes, and also previous experience, either through participation in a course or a workshop or full-on training in science communication. And we really view our study as a case study of physicists, which may reveal a profile that is also generalizable through a broader group of scholars. But we really wanted to focus on specifically physicists in the Netherlands because this group just hasn't been studied yet. So this leads me to our research question, which is how do physicists employed at Dutch academic institutes perceive and practice science communication? And we actually had 3 hypotheses going into this study. So first is that physicists actually rely on the deficit model to educate the public on physics-related subjects. So this would actually indicate an adherence to the PAS model. Then there's physicists that do not really consider the public's engagement with physics throughout their research, which would then indicate a lack of adherence to the PAS model. And lastly, when we think about strategic science communication, we thought that physicists would view science communication to be useful when it really benefits their own academic career. So that, again, would indicate adherence to the SSC model. And before we dive into the results, let's have a look at how we designed our study. So I mentioned NWO physics already. But for international context, I have to go into the details of this a little bit. So this is actually a large conference in the Netherlands that annually highlights the latest advancements in physics. And our research team was actually granted a 20-minute time slot during an evening dinner at this conference, where we made use of questionnaires and questionnaire-like research. And our approach to our study was actually threefold. So the first was actually that we wanted to introduce physicists in the Netherlands to science communication in general, because it may be a vague or a broad concept for them, or they haven't even heard about science communication. So we also really wanted to do that first. And then, of course, was our research. So we wanted to solicit them on their views and attitudes towards science communication. And lastly, we asked ourselves the question, can one actually conduct questionnaire-like research at scientific conferences? Spoiler alert, I will tell you about this at the end. So our study design is that we actually asked physicists to engage in a fundamental quiz during the evening dinner when we were on the stage. And then we also asked them to engage in a follow-up survey, which would include more detailed questions about science communication. So this was the more traditional approach to our study, because we also use promotional material and email reminders, for example, to engage them in our study. And the fundamental quiz was really the novel part of our study as well. And then we grouped our survey items according to the mental models. So we also designed these survey items according to the mental models, and then we grouped them and averaged them. And we performed our data analysis through linear regression. So again, a visual journey. On the top left, you can see me on stage, and I was asking people here to engage in the Kahoot quiz about science communication. And then on the bottom right, you can see me asking them also to participate in the detailed questionnaire. So now that we all know this, let's go into the results. So first, let's revisit hypothesis 1, which was that physicists would rely on the deficit model. And before I explain to you what we did find, I have to explain a little bit more about how we constructed our questionnaire. So we made use of Likert scale from 1 to 6, where 1 would indicate strong disagreement and 6 strong agreement. And when grouping and averaging all the survey items, we then assigned an alignment score, also on scale from 1 to 6, where 1 would indicate actually weak adherence to a mental model and 6 strong adherence to a mental model. So what did we find? For physicists in general, we actually found a weak adherence to the PAS model, which would then reject hypothesis 1. But we also dived into a more specific subset of physicists. So when we actually look at physicists who communicate quite frequently and those who communicate through audio and video-like platforms, we actually found a higher alignment score, which would indicate a mild adherence to the PAS model. So we actually only accept our hypothesis 1 for a very specific subgroup, and it also indicates the impact of the frequency of engagement in science communication and what science communication formats can actually mean. So when we look at then hypothesis 2, we need to revisit the hypothesis as well. So we thought that there would actually be a lack of adherence to the PAS model. Again, what did we find? There's actually a mild adherence of physicists to the PAS model. So with a 3.35 alignment score, we can actually say there's a mild adherence. And again, looking at a specific subgroup of physicists, we saw that again, those communicating frequently show a higher alignment score, which would actually indicate a strong adherence to the engagement model. And now we can also say that the frequency of engaging in science communication actually not appears to be an indicator only for PAS, but also for PAS. So let's keep this in mind also when looking at our last hypothesis. So this was that a physicist views science communication to be useful when it benefits their own academic career. And here we already looked into a specific subgroup because over the general population, we didn't find a strong adherence to the science communication or the strategic science communication mental model. But when we look actually at tenure track physicists, so we saw that there is actually a strong alignment to the SSC model, so to a strategy in science communication. And I have to note here also that this group included those, again, communicating frequently, and those who also use social media to stay up to date, for example, on scientific developments. And we also looked again further into the subset of physicists, and we saw that the alignment score is even higher for physicists who communicate through audio and video-like platforms. So what we can say from this data is actually that the frequency of science communication appears to be a general indicator, not only for PAS and PAS, but also really for the strategic model. And we can appreciate here that academic seniority seems to be a unique indicator for the strategic science communication mental model. So with that, let's move towards our implications. So I told you I would come back to this, and we actually conclude that collecting questionnaire data at professional conferences can really add valuable insights into the field of science communication. We also found that the frequency of engaging in science communication efforts is a significant predictor for physicists' alignment with all science communication mental models. And we saw that career stage and communication formats appear to be significant predictors for alignment with strategic science communication. And here we really saw that career stage is then unique for SSC, and communication formats are both apparent for the PAS and the SSC model. Moving forward, we would really like to follow up this study with qualitative research, specifically with tenured physicists. And then we would like to look into the role also of academia. So how does the tenure attainment impact attitudes towards science communication? What role does then strategic communication play here? And is there maybe an attitude shift throughout the trajectory of attaining tenure? And before I wrap up my presentation, I would like to end on this note. Because there's also, of course, a need for physicists that needs to be addressed. And in our survey, we also asked, what can we as science communicators actually mean for you, for the physicists who are interested in science communication, but maybe are just not sure where to start? And we actually found that around 50% of physicists in our survey call for practical tools to design a science communication activity or for recognition of science communication as part of their work activity. And again, like I said, this also may be generalizable to a broader group of scholars, and I think we've already discussed this in the previous days as well. So I would really like to encourage you to think about how we can shape a sustainable future for science communication in academia. Thank you.